Hello, my name is Jennifer, and I'm here to introduce of our projects on behalf of my group. And the other members in our group is Ludan, and the our project is named Machine Learning for Personality Prediction based on social media posts using MBTI. So first, let me introduce what is MBTI. And personality classification is a critical area of study in um, psychology, with the Myers-Briggs types indicator serving as one of the most widely used terms for personality classification. And it can be divided into four dimensions. And the first dimension is extroversion and introversion here. And extroversion, which means that a tendency to draw energy from the outside world. Extroverts enjoy interacting with others and generally feel charged and um, energized in a crowd. And introversion, which means that a tendency to draw energy from one's own inner world. And introverts prefer solitude and often needed to be recharged. And the second dimension is sense and intrusion. Sense, which means attention to reality and specific details, preferring to rely on known facts and experiences. Sensory people usually focus on the specific, quantifiable information, and the intrusion tends to focus on the big pictures and on future possibilities, and prefers abstract ideas and theories. And intuitive people are good at association and like to think about future potential. And the third dimension is thinking and feeling. Um, the tendency to here thinking is a tendency to rely on logic, objective criteria, and rational analysis when making decisions. And thinking people tend to think efficiencies and fairness. Next one is feeling, um, which is placing greater values on personal values, feelings of others when making decisions. Affected people focus on relationships and emotional needs to and tend to empathize. And the last dimension is judgment and perceptions. And judgment, which means that it likes to be organized and planned, and prefer to be in control of life, and likes to make decisions ahead of time and carry them out according to the plan. And here the last one, perception is more flexible and prefers to keep options open. Um, Perceptual people are usually more adaptable to change and like to adjust their plans on the fly. The MBTI combines these four dimensions to form 16 personality types. For example, if someone is ESTJ, which means that it includes extroversion, um, feeling, thinking, and judge. Um, they will usually a methodical, programmatic leader who likes to plan and organize. And if someone who is INFP, which means that it include introversion, intrusion, feeling, and perceiving. They're usually idealist, valuing personal values and emotions, and inclined to create and explore new possibilities. And here, so Social media platforms have become a significant source of behavioral and psychological data. So motiva- our motivation is to leverage the MBTI model, and so that we can better understand user characteristics and provide more accurate decision support in areas such as marketing, recruiting, and content recommendation. So our project, the target is just to find the best model to fit our data. So our project can be divided into three parts. The first part is data collections and processing, and second part model training and selection, and the third part is um, model evaluations and comparison. So first, our data is a popular MBTI dataset from Kaggle, including the user's MBTI type and one of their posts. And we also make some visualization to observe the data distributions and characteristics. Next, we also make the data processing, including transform each MBTI type to binary vector, remove the noises, and do filter engineering. And the second part, we make the model training and selections. And in this part, we choose logistic regression, KNN, XGBoost, SVM, and we also created a voting classifier using logistic regression, SVM, and random forest to fit our data. The last one, we also try to use a deep learning models, which is fully connected neural network, which also called FCNN, and combined with Keras framework. And the last part, we did the model evaluation and comparison with the aims of choosing the best model for fitting our data. So now I will start to introduce our code. Here we import the required packages and import our data we have downloaded. As I have talked above, it includes two columns, MBTI type and the user's posts. And each rows of the data represents a user. And here we can see there's no known values in our dataset, and the numbers of rows is 8,675, and all values here we can see are text rows, so we should convert it to numeric form for using models to train our data. So the data set includes here. You can see the data set includes 16 types of MBTI type, which means that it has covered all the MBTI types in data. So here, from the word count, the post contains general words like here I, to, the, a, and, etc. We assume that this word don't really provide any useful information to train the model, as most of them are stop words or other useless words. Also, we make the visualization. The first graph, we make the total word cloud map, and you can see it really includes lots of words which is useless for our project. We also make the word cloud map for every MBTI type, and MBTI type, and we can see there are a number of irrelevant words present in the dataset, such as here we can see a V, W, which is useless, and which means that we need to remove them. And interestingly, among the most common words in word clouds of individual personality types is the names of MBTI themselves, and you can see here ENFJ, and here. So it would hence be necessary to clean our post by removing these MBTI words from each of them as part of our processing stage before training the model for better evaluation result. And here, the above code assigns the values of 1 to individuals who possess the traits of introversion, intrusion, thinking, and judging, which also called I, N, and T, and J on 4 S's of the MBTI. I versus E, I versus S, and F versus T, and the J versus P. All other individual is equals assigned to net values of 0, and this allows us to calculate the numbers of poles that would correspond to introverted individual versus extroverted individuals out of all insights in the label cargo data list. And this analysis is conducted to examine the dataset for each individual personality index of MBTI. And here we can see that there is an uneven distribution of insights in our dataset here and here. With the E being the majority in the IESs, and S being the majority in the NSSs, and here's a relatively less difference between T and F in the TFSs and J and P in the JPSs. And here, so here in the data processing step, we remove the stop words and MBTI type name. We also unify their case. And here we removed the useless characteristics such as the URL links, the written words, also the spaces over 1 and some multiple letter repeating words, and also our stop words, the MBTI personality words, and here we also transform MBTI to binary vector, which is an important step for model training. So in our model, we also use TF-IDF feature engineering to determine the relevance and importance of a word in relation to a document within a collection of documents. And this technique is particularly useful for training individual classifiers and scoring words in machine learning algorithms for natural language processing. And we vectorize the dataset using both con vectorizers and TF-IDF vectorizers, while only keywords that appear between 10% to 70%. So therefore now we have 565 features for each user post, and we also splitting them into X and Y variable. here we can see X is the user pose in TF-IDF representation, and Y is the personality type in binary form. Finally, here we can see the pose, how the pose looks in TF and TF-IDF representation. For example, here is the first pose in data. This non-zero values represent combinations of the frequencies of the words occurrence in the documents and varieties of the word in the entire corpus. The higher the value, the more important the word is to the document. So finally, here we can see we have successfully converted the textual data into numeric form. The first model is logistic regression, which is an ideal model for binary classification problems. And here we first divided the data into 33% of the data into testing data set, and the rest of it, which means 77% of the data set, into the training set. So after here the model training, we can see from the results that the prediction accuracies of this model for the third dimension is respectively here 77.54% and here 86.06% and 72.44% and here 64.51%. We also make the graphs of ROC, and it can be seen that the performance of the classifier in FT is excellent, because you can see here the AUC value is up to 0.8. So the second model is KNN, which is a simple and intuitive, suitable for smaller datasets with fewer features, and does not assume the specific data distribution. And here we specially make the experiments on the selections of k-value, and we found that when the k-value is greater than 4, the model accuracy tends to be stable, and the training set accuracy and the testing set accuracy fluctuate around 67% and 55%. In general, compared with the above logistic regression model, we think that the KNN model is not good for our data fitting. And the next model is XGBoost, which is abbreviations of extreme gradient boosting, and it is based on a framework called gradient boosting, which improves efficiency and accuracy through accelerations and optimization. Gradient boosting decision tree, which also called GBDT, is an ensemble learning algorithm that makes predictions by combining multiple weak learners, which is like a simple decision tree, just to combining them and into one strong learner. And here we use the decision tree, and here we can see from the results that the prediction accuracies of this model for the 4 dimension is respectively 76.18%, 85.37%, and 67.73%, and here the 62.84%. And here is the model is SVM, which also called support vector machine. And its main task is to find a hyperplane that can maximize the separations of different classes of samples. Ideally, this hyperplane should be able to keep different classes of samples as separate as possible, while maintaining a large margin, the minimum distance from the sample to the hyperplane. And in this model, we can get the result as respectively 77.89%, 86.03%, and 72.86%, and here 64.9%. And next we using logistic regression, random forest, and S3M models to create a voting classifier, and we use hot voting here, where the majority is subordinate to the minority to classify the data. And here we also can get the accuracy 66.14%, 86%, 71.57%, and 63.19%. So finally, we use CNN to feed data here, which has a simple structure but can solve many classification, regressions, and other problems. It consists of multiple layers of neurons, hierarchical structure, and usually including the input layers, hidden layers, and output layers, with neurons in each layer having connections to each neuron in the layers above it. So here we set the epoch equals to 3, which means that we set the numbers of exercises to 3. So here is our result is respectively 70.93%, 86%, which is similar to the above model, and 71.92% and 64.41%. And here is our result. So now here we just combine the results of the model we used above in the table to make a comparison. Here is the result we get, and here also including the times of the time error model used, and you can see here is have a difference with each other. Among all models, we applied the prediction accuracies into 2 dimensions of IE and NS is higher. We think that this may be related to the large difference in the numbers of samples, as we have talked above, corresponding to these 2 dimensions in the dataset, which makes the model more accurate in predicting categories with more samples, but weak in identifying a small numbers of categories. And we think there is no significant difference on accuracy between these models, so we hypothesize that because this dataset is relatively simple, simple models such as logistic regression models also can make good predictions. However, the complex models such as voting classifiers and FCNN do not show the better prediction rates for the same data. So, since there is no much difference in accuracies of predicting MBTI among these models, so finally we prefer to choose the logistic regression models because it has a less computing power and have a similar fast prediction speed and accuracy. So that's all. Thank you.